Universal law of gravitation. Suppose this is one body of mass m1 and this is a body of mass m2 and the distance between them is r. Now according to the universal law of gravitation, every body in the universe attracts every other body with some force. So m1 is attracting m2 and in return m2 is also attracting m1. Okay, and what more further he has told about that particular force, that this force is directly proportional to the product of their masses, that is m1 into m2. So F is directly proportional to m1, m2, as well as it is inversely proportional to the square of the distance between them. The distance between them is r. Square of the distance is r square. So F is directly proportional to m1, m2 and F is inversely proportional to r square. Okay, so this much is clear. Now going ahead, we get, if we combine both, we can write F is proportional to m1 m2 upon r square. Okay, now we will change this proportional sign into equal to. Whenever we do that, you know that one constant is introduced. So G is the constant. M1 M2 upon R square. Now this G is known as universal constant of proportionality. It is known as gravitational constant. What is this G known as? Gravitational constant. Whenever you convert a proportionality into equal to equality, you have to introduce one constant. You are knowing that. In maths, you have done that. Okay. Now, going further in this, we will see. Again, come to the same. This is body of mass m1. This is body of mass m2. And both are having they are situated at a distance r. Okay. Now m1 is exerting a force on m2. m2 is also exerting a force on m1. Now the force exerted by m1 will be known as F12. Force of m1 on m2. And force exerted by 2 on this will be F21. Force of 2 on 1. Okay. So this is how we represent the force. Now these two forces are always equal and opposite in direction. So we can write F12 equal to F21. Now the magnitude is equal but direction is opposite. So I will give a minus sign over here. So F12 is equal to minus F21. Okay. Next. Now we have seen that F is equal to G m1 m2 upon r square. Now I want to find for G. Now G will be equal to what? F into r square cross multiply upon m1 m2. After putting the values, we have found out that value of G comes out to be 6.67 into 10 raised to minus 11. Now what about the units of G? Dekho. Force means Newton. R means what? It is meter, but it is r square. So meter square, and that will be divided by m1 m2. m1 m2 means what? Kg into kg, that is kg square. You can also write it as Newton meter square kg raised to minus 2. So this is the unit of the universal gravitational constant. Okay. Now suppose if you take m is equal to 1 kg, m2 also 1 kg and r is equal to 1 meter, then F will become equal to G. So here you get the definition of the gravitational constant G, that it is numerically equal to the magnitude of the force of attraction between two masses of 1 kg each placed at a distance of 1 meter. Okay. Then there is one example given, just solving after substituting the values. Okay. Then you have some properties about gravitational force. Let us see what are these properties. First is, it is always attractive. See, forces are either attractive or repulsive. Attractive force जो अपने पास लेके आता है, repulsive force जो दूर भेजता है, okay? जो push कर देगा, that is repulsive. जो pull करता है वो attractive. So gravitational will never push you aside. It will always pull you towards itself. So it is attractive in nature. Then it is directly proportional to product of the masses. It is inversely proportional to the square of the distance. More the distance, less will be the force. More near it will be, means less will be the distance, the force will be more. Everybody knows that. जितना दूर जाएंगे, the force of attraction will reduce. More near you will be, the force of attraction will be more. Now the heavenly bodies, that is the planets, the satellites, they all have the gravitational force, and it is very significant in them. Okay, because they are very big in size, but in people like us, even I have a gravitational constant, even you have, but then it is negligible. Why? We are not able to just pull somebody towards us, how Earth pulls, because our gravitational force is very, very small compared to the heavenly bodies. They are very large. Okay. Now what is the importance of this law of gravitation? Because of this law of gravitation, Newton was able to explain the motion of planets. Why Earth is going around the sun? Why Moon is going around the Earth? Why? Because this is the sun. Okay. And okay. This is the sun. And this is the Earth. Both are attracting each other. But the force of sun is very much greater than force exerted by the Earth. And because of that, what happens? Earth goes round and round the sun. In case of Moon and Earth, the force of Earth is more than the Moon, so the Moon goes around the Earth. The one who is weaker will go round and round. It is just like, you say, here there is a person who is catching a small boy, okay, and the boy is trying to run away and the man is catching him, not leaving his hand. So what will happen? He will go round and round. The same thing is happening over here. So this is the importance of this law. Because of this law, he was able to explain why these planetary motions are there, why they are revolving around some other body, and also the freely falling, like this is the Earth. You have already studied in the other videos, okay, why a thing falls down. This we came to know because of the gravitational force. So these two things are explained because of the law of gravitation.